Our next speaker is Andrew McCormack, which is a senior expert in security, working in UKERNA, the UK Research Network.
I hope this is where I show the benefits of wearing a tie. But, it gives me something to clip that onto that won't fold away. Something else to do. Carry on, you do that. I think the title of this conference is very interesting. User Opportunities / Network Challenges, which suggests that there are, if not conflicting pressures going on, at least competing pressures. What I'd like to do for the next, I think I'm allowed to speak for 20 minutes, is put you in the position of the people who very often end up having to strike the balance between those two competing pressures, demands of users and the demands of network developers, network technologies, which is the network managers. Because nowadays, every network has a manager. When I started, I remember a wonderful 2.4 kilobit network connection between two universities in the UK. I'm older than I look, possibly. And it was great. And a 2.4 kilobit network doesn't need a manager because there's so little you can do on it. You can only actually use it for one thing. So there's no management involved. Whatever gets to do it, use the network today, is it. Nothing else happens. However, as networks get faster and faster, people start using them for other things. Nowadays, people are using networks. My background is in universities, so most of these are slanted to universities, which people don't think of as critical organisation. But for most universities, networks are now critical. They're using them for teaching. We have a number of universities that use the national backbone network for sending lectures from one site to another, which means that if the network is not there, there is a class of students sitting in a lecture room looking at a TV screen with nothing on it. That network is absolutely critical to those students. We are certainly looking at universities using networks for administration, for sending in grant applications. I have had, this is going back 5 years, I had a researcher phone me up in tears because the mail server that I was running had had a hardware failure, which meant that his application for, I think it was £500,000 of grant, had not reached the funding body. I did suggest that I was touched by his trust in technology, that he did not phone them to check it had got there. Now, to put £500,000 in a single email, that's incredibly trusty in technology, and technology isn't that good. So these applications, the network is critical. Network's critical in at least 3 ways. It's time critical. For some of these applications, the network has to be there at 10 o'clock on Monday till 11 o'clock on Monday. Bandwidth critical, applications will use all the bandwidth you can give them. So the amount of space on the network is critical, and they are reliability critical. I have a strong suspicion that the majority of network faults in the UK are now due to people digging holes to put networks in. 1 or 2 other countries are agreeing, I think. As far as I know, we haven't yet dug up our own network, but I think it's only a matter of time. But it's still, we're now running at 10 gigabits. Sorry, it's finite. It's not infinite. So somebody needs to say, when there is competition between these demands, that is a higher priority. That is more important than that other thing. And we hope that decision is not made by the network manager, because it's not the network manager's business. But it is the network manager's business to implement whatever decision the organisation has made that, at the moment, it is exam time. My wife administers exams for the university. She thinks examinations are pretty important at the moment. Another month, she won't care. Well, she will, but it becomes less important. But somebody in the organisation needs to say, this is important. We have a major lecture happening. That is what matters at 10 o'clock on Monday. It helps the network managers if that's written down. That doesn't happen in many organisations, unfortunately. But what this means is that if you want your applications, the protocols that you write, the services you write, the things you use, to be there when you want them, you need to allow the network manager to make the decision that this traffic is important today. And that is hard, because network managers are told video conferencing is important. I have yet to see a packet on a network which says, I am a video conferencing packet. They don't do that. They say, I'm going from this server, that port number to that port number. And that's it. It doesn't say, I am the vital video conference. I am the email that your £500,000 research grant depends on. So somehow the network manager has to translate the piece of paper he's been given that says this is important into this packet or that packet. And the only way to do that actually is a huge series of assumptions. And protocols can be designed to make those assumptions reasonably good, or they can mean that there are no assumptions you can make at all. What managers want is that, slower build than I thought, is that services are identifiable. A service, in the terms that users think of them, can actually be recognized on the network, that this packet belongs to that service. That's identifiable. They need to be controllable. If I'm a network manager, I want to say it's important that the video conference goes to the video conferencing suite, but I really shouldn't be running video conferences off to the principal's office. As we heard earlier, desktop video conferencing has not yet taken off. So I need to be able to say, this is allowed there. And the converse of that, I need to say, it's not allowed there. Telnet should not be allowed on your administrative network. Maybe fine somewhere else, maybe fine in student residencies. Probably isn't, but I want to be able to say things like that. The assumptions you can make are, third one. I don't have builds on the paper version. Protocols should be non-hazardous. In terms of RFC speak, the fact that I choose to use a service must not increase the hazard to other users of the same network who are not interested, not participating in that service. And my use of the service should not. I'm using it, I can be expected to maybe take a bit more risk if I'm justified, but should not be a hazard to me. And increasingly services are failing those tests. The assumptions you can make, well, there are some that are sort of reasonable. If I see something going to port 80, it's probably web. I've seen a number of packets floating around Zone Alarm on my laptop which come from port 80, which I know damn well aren't web because hackers will forge source ports. It would be nice if IP address, or addresses, at least in terms of address pools, identify location on the network. Whether that works on wireless LANs, all sorts of wandering things. Is this my machine? Is it somebody else's machine? And I will try and assume that the source, at least on the initial SYN packet, is the client machine and the destination of that packet is the server. Or, since we're in a peer-to-peer world, stop talking about clients and server and at least say the machine that originated the SYN packet is the initiator. It's the thing that asked for something to happen, and the other one is the responder to that. You're forced also to make some dangerous assumptions, that an IP address identifies a person. Controlling access to administrative systems by IP address. So the principal's IP address is allowed to access anything on the finance system. Then he sends his PC into the network repair, so the PC repair center with a network fault, and the first thing they do is swap out the network card and put a different one in. We use DHCP. So whoever gets his old network card is now him, as far as the network's concerned. We spotted it just before the network card was reused. It was one of these horrible moments in the coffee room where a number of people went, simultaneously. That network card, now who needs a smart card? If you're doing this, that Ethernet network interface card is your ID. The traditional Unix assumption, anything with a source port less than 1024 is trusted. Because on Unix, to be port less than 1024, you've got to be root. And everybody knows you can trust root on any system. Okay, doesn't work on Windows, never worked on Windows, because you can bind to any port you like on Windows. Assuming that root on that thing is trusted, no, doesn't work. But in some cases, you still have to do it. So I picked 3 protocols to look at how well do they fit those requirements of identifiability, controllability, and hazard, which I hope will give an idea why, when you talk to network managers about some protocols, they smile, they sit back, they look relaxed. And when you talk to them about others, they start spitting. HTTP, I will say that there has been a character set failure somewhere between the UK and Croatia. If you see a yin-yang symbol, assume it's a tick, because it was on my machine. HTTP, nice and simple. Destination port, who knows what. So source port, who knows what. Destination port, always 80. From a random workstation to something that I probably know about. I've got a web server on site. I know it's a web server, I hope. Yeah, okay. At the client end, it's identifiable. I can assume anything going out with a source port, with a destination port of 80 is web. It's controllable, because I can say that machine is a web server and that machine isn't. In fact, I can put a big control up here that says port 80 just doesn't come into this machine at all. The web still works very nicely. Hazardous? No, because I can do precisely that. Anybody in the room, anybody on the campus can see websites outside with no possibility of inbound TCP connections. At the website end, well, it's identifiable, it's controllable. There is a hazard. But if you're running a web server, you ought to be prepared to protect yourself against that hazard. So my 2 network managers are reasonably happy. Next protocol, FTP. Port 21, outbound, control connection. Yeah, data connection coming back the other way with a source port of 20. Remember what I said about hackers forging source ports? You will see source port 20. You will see source port 53. The DNS response, isn't it? No. Maybe not. So how does this one pass? Well, it's sort of identifiable at this end, because I can at least identify the control channel going out. It looks just like a web connection, but 21. Controllable? Well, sort of, because if I allow one workstation in a room to do FTP, I have to open up this return connection, which probably means I have to open it up to all of them. So it's not great for controllability. And hazard, big hazard. Anything with a source port of 20, I have to allow in, unless I've got a nice smart firewall sitting in the way that can see that going out and say, there's going to be one of these coming back again. Not great. The FTP site end, it's actually the same as the web server. It's identifiable and it's controllable, and it's a bit of a hazard, but you ought to be able to live with that. So the server end network manager is happy, but the client end network manager has a problem because of this need to allow inbound connections to things that are actually clients. They're initiating services, initiating requests for services. Number 3. This is really showing off how I can do animations in PowerPoint. Okay, sorry, passive FTP. Right, we've solved that. A thing called passive FTP, which addressed this problem of the inbound connection by saying, no, the data connection will be established in the same direction. So stuff is now going from the client to the server all the time. Good. Unfortunately, there are now no known port numbers on this thing. So there is no way I can identify that packet anywhere, which means it's not identifiable, or at least this flow isn't. And of course, if I'm worried about network capacity, bandwidth, reliability, this is the big flow. That's the one I actually want to be able to manage. So I've got rid of hazard, at least at this end. The hazard at that end is terrible, because I have to allow connections from anything to anything. But this end, well, okay, he's a bit happier about the hazard, but at the cost of being unable to manage the traffic, and at a big cost for the server end, that he now has to open himself up to everything. So there are trade-offs. Number 3. This is, I think, how Napster worked. This is all done by reverse engineering from actually observing what packets flow around. Not by me, by various people on the web. Right. When you start Napster, you made a connection off to a well-known server. Well, 256 well-known servers, but we can cope. Right, on one of a number of ports, somewhere between 4,444 up to 8,888. Yeah. And then all hell breaks loose, because suddenly my initiating client creates and receives connections on at least 6 different ports in there, and more. The and more is where the reverse engineering breaks down. And also UDP packets on unknown ports, completely randomly. Nobody's happy. Can't identify it, because all of these might be used by something else. Can't control it, because if I allow this to happen anywhere, I've got to allow it to happen everywhere. And hazard, yes, because if I allow it to happen anywhere, then every machine on the network is exposed to any port, any packet with these sorts of characteristics. And because it's not defined what these sorts of characteristics are, I can't actually produce restrictions that I know will allow Napster through, other than saying everything in the world. And actually, that is why network managers hate Napster. It's nothing to do with copyright. All the complaints about peer-to-peer file sharing that I got for about 2 years, both as network manager at a site and as head of CERT, were about bandwidth and about unpredictability and about billing, because in those days we charged sites for every packet they send across the Atlantic. And they came back to us and said, our bill for last week was 10 times, or last month was 10 times what we'd expected it to be. And that gets people excited, not just network managers. So that was why Napster got banned. Not because it was against copyright or anything, just because it was unmanageable. There are a load of future developments in networking which you might hope would help on this sort of thing. In fact, it turns out they don't make a lot of difference. Dynamic address allocation is fun. It throws away that assumption that you might make that this port corresponds, so this IP address corresponds to this person. You can't do that if you're doing DHCP or NAT. But as I said on the earlier slide, that's a dangerous assumption anyway. What it does mean is if you are trying to manage, use my controllability test to say over here but not over there, you can't share an address pool between here and there. So you've got to partition up your address pools to match the controls you want to put on the network, which needs a bit of thought and a bit of planning. And you hope you get it right first time, because changing it is a mess. You suddenly decide that this subclass, and you have to split up your address pool, and life gets messy. IPv6 doesn't actually change manageability in the sense that packets still have sources and destinations and ports. So you've got all the tools that you had before. However, IPv6 is designed for fast routing. Routing, you only need the addresses, you don't need the ports. Mara pointed out that this means that the port number may actually be a long way down a chain of headers. So you may need to do quite a lot of processing on routers and firewalls to find out what port an IPv6 packet is going to, because IPv6 packets assume that's handled at the actual destination machine. And of course, if one of the headers beforehand is an encryption header, then you can't see the port numbers anyway because they're encrypted. So that may make life hard. Mobility in terms, mobility may turn up in IPv4, but it's mainly an IPv6 issue. It's actually just the extreme of dynamic address allocation in terms of manageability. So if you can work out how to handle NAT, you can probably work out how to handle the mobility issues of IPv6. So, in conclusion, if you want your protocol to be welcome, what's the protocol, the characteristics of protocol that makes a network manager happy? Identifiable traffic flows. which means well-defined and appropriate use of reserved ports. The appropriate is interesting. I put up HTTP as my ideal protocol. It's clean, it's simple, it's one TCP connection. It's a terrible design for actually doing what HTTP was originally there for. It should have been UDP, but it wasn't. It was TCP, which is good. The problem now is because HTTP is welcome on networks, people are channeling everything down HTTP. You look at web pages. I've been browsing my email using HTTP. Well, in the old days, I could actually manage email and web separately because there was port 143 for POP, and there was port 25, and there was port 80. Nowadays, I'm ramming everything down port 80. People are managing routers down port 80. I might like to manage that differently. To say, no, only network management stations can manage routers. Can't do it. Because it's all flowing down this wonderful HTTP protocol that goes everywhere. Of course, nowadays, peer-to-peer software will flow down port 80 as well. Never mind. Clarity over relationship between hosts is great. Even in peer-to-peer, the two machines are not actually peers. One of them said, I want to do this, and the other one said, OK. That's fundamentally different. And it would be a real help if protocols actually made it clear which was which. And TCP probably does. UDP doesn't. If you're using the same port numbers at both ends, life is messy. And I'm sorry, the end-to-end model is great in theory. It assumes that your ends are perfect. I asked last year in one of the plenary sessions, who secures this great all-encompassing peer-to-peer system? And I was told the users do. I think I was told, of course, the users do. OK, so your peer-to-peer network runs on perfect software and has perfect users. Nobody here in the past 24 hours has clicked on an email from support@microsoft.com, have they? Public health announcement, don't. Interesting virus. So there are going to be firewalls. There are going to be some protocols. I was asked yesterday by one of my customer sites, my principal wants to run net meeting. How do I get this through my firewall? Yeah, it's not quite as bad as peer-to-peer, but it's nearly as bad. Be prepared for the fact that there may be proxies there. Be prepared to write the proxies. I'm a network manager. I don't do code. I don't really want to understand protocols and processes and what you're doing. But you're the ones who are designing grid FTP and all this authentication stuff. While you're writing that, can you write the proxy as well? So I can actually control it at the application layer. Because if you do that, you'll actually be welcome on my network. Yes, please, I'm happy to run you. Horrible story at the TAC yesterday morning about a couple of grid sites who decided to do an experiment. Didn't tell the national network provider and cut a number of sites off their network for 3 days, I think it was, simply by flooding it with bandwidth. And the network provider jumped up and down on them. And it sounded as if the users were surprised that this was not a welcome thing to do on a national production network. Really, the plea is give managers options. Any protocol gives managers two options. Yes, I'll let it in, and no, I won't. If that's all the options you give network managers, don't be surprised when they choose the second one. Thank you.
Thanks. Questions?
What do you think about solutions like Packeteer that attempt to identify traffic at the application layer?
I think, from a network manager's point of view, I want them. They're brilliant. They will look into packets, but somehow the packet has to be recognizable. Give me a feature, give me something that I can say, if the packet looks like this, it's one of them. And because those nice grid people have come to me and said, we're doing a vital experiment, we've got to ship a load of packets next week, and they look like this, I can say, yeah, great, I will set up my system to let them in. And I don't immediately think, my God, it's a denial of service attack. Yeah, the states are using Packeteer and the like immensely on student residencies because they don't feel politically that they can simply put in old-fashioned yes-no blocks, but they can just about recognise the traffic flows with Packeteer and say, okay, each student can have 5 megabits, 10 megabits. There's some quite subtle ones that actually now allow you to give them, if you like, a certain number of megabytes per week. Or you can presumably even ramp things up over the weekend when who cares, and squeeze it down during the day. They're very, very nice. But it relies on the protocol. It's still a nightmare trying to control peer-to-peer separately with those. You tend to catch all the web stuff. Or else you end up doing reverse masks and saying, well, everything but web, mail, blah, 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 is peer-to-peer. But yeah, they're great. But they do need help, even those.
Other questions? I have one question, which is the basic of these kind of things. How do you match the requirements with privacy? And trackability and logging and so on. I mean,
yep. I ran a network security. I managed services. I did a bit of network management. I ran a security team. I'm now drifting, God help me, into regulation. And my reading for the flight over here was a government consultation document, which I really don't recommend to anybody. So, yeah, unfortunately, I'm having to look at traceability. Actually, traceability isn't always about tying something down to a person. It's tying something down to a signature or an undertaking or some money in a bank somewhere that says, if things go wrong, here is your recompense, here is your comeback. So I hope there are ways to avoid really having to do really intrusive monitoring. But again, if you can make the applications help, interesting comment from Ken earlier about get a handle on the difference between authentication and authorization. I will show you in the real world the difference between authentication and authorization. That's an authentication token. It's my business card. Great privacy implications. You take that, you know I was here, you can prove I was here. Authorization token? Authorization token. No authentication. That's anonymous. And it's far better for buying a beer than that is. That's the difference.
You didn't say anything about the access lists, inbound, outbound access lists.
They are good. They are getting harder to do because there's only 65,536 ports out there, and I suspect... You can indeed. It's my option too. I will block all inbound ports. I have certainly been at conferences where people have said, of course we block all UDP. This predates certain recent applications. Yeah, but they're a very crude tool. I've always got them. They are my tool if nobody gives me any help. Yeah. But that's who do you want to write? It's like Napster. I could sort of maybe, using public documentation that people have done by reverse engineering, write you a dynamic Napster set of access rules, access lists, that would open up the ports it needs to, just like an FTP. You can buy routers that will do FTP. We'll say, okay, connection outbound, what was the ports it requested, connection back inbound. It's quite easy to do those with a documented standard. But it's even easier for the people who wrote the implementation to write the proxy. Don't leave it up to people who are trying to interpret standards, and will get it wrong. The urgent bit Anybody remember was it ping of death? It was a ping that depended on how you interpreted the urgent bit, whether it was a pointer to the first urgent byte or the last non-urgent byte. And it turned out PCs made one assumption and Macs took the other one. So Microsoft fixed the attack. It crashed Windows NT, I think, back in those days. Microsoft fixed Windows NT for the attack as long as you compiled the attack on a Windows box or a Unix box. But if you compiled exactly the same C code on a Mac, then you still crashed it because the Mac was off by one, or possibly Windows was off by one. But it's the people who write the implementations write the bits in the middle, because otherwise you'll get those nasty little misunderstandings. And a lot of protocols, you only need to lose one packet and the whole thing breaks. I had some fun getting Zone Alarm set up so I can watch the streaming from here as to, okay, where are these packets coming from? Most of them were getting through, but the odd one wasn't.
Let's thank the speakers again.